An extensibility approach for spatio-temporal stream processing using Microsoft StreamInsight. My name is Jeremiah Miller. In this demo track paper published in Advances in Spatial and Temporal Databases, 2011, my co-authors and I present a scenario where a number of mobile devices, such as smartphones, stream their current geographic locations to a server that performs real-time spatial queries on this data stream. The current proliferation of location-enabled mobile devices, such as smartphones, provides a wealth of opportunities for solutions that leverage spatial queries over these moving point data streams. We implemented two classes of such queries in our demo solution: KNN queries, such as find the 3 nearest gas stations, and range queries, such as find all vehicles within a window around mine. Our solution is built on Microsoft StreamInsight, which is a commercial complex event processing engine. We rely on it to handle the temporal complexities of events in the data stream and to process our queries over the data stream. Unlike other products on the market at this time, StreamInsight is extensible by user-defined operators, also known as UDOs, making it an ideal choice for our solution. We wrote UDOs for performing spatial queries and invoked these UDOs in standing link queries run by the StreamInsight runtime. Our solution architecture involves mobile devices sending their locations over the internet to a server running StreamInsight. We wrote an input adapter that receives the incoming events and provides these to the StreamInsight runtime, which, in turn, runs a standing query on this data stream. The query invokes our spatial query operator, which updates a spatial index and queries that index for the mobile devices that match the spatial query parameters. The results are streamed to an output adapter that displays the query results. In the first part of our demonstration, we show the solution working with several smartphones. On the right, you can see the smartphone app that we built that streams its position to the server. The smartphone app also shows its own location on screen, as well as the locations of other devices that matched or did not match the spatial query parameters. On the left is a desktop output adapter, a Silverlight app responsible for controlling the server and displaying the query results. The red place marker is the location of the query phone, which is the phone whose screen is shown on the right side of this video. Blue and orange place markers show the locations of other phones. Orange place markers are those phones that match the spatial query criteria, and blue place markers are the phones that do not match the criteria. The blue phones are only shown for the sake of demonstration. A deployed solution would have no need to output these non-matches. As the phones run for a while, we can see their place markers move as they acquire more GPS satellites. This causes the positions of some of the phones to fall inside the query parameters and turn orange. To help illustrate that the UDO is operating correctly, we show a dark gray box around the query phone on the desktop output adapter on the left. This is the outer boundary of the query range. If the solution is working correctly, any device should turn orange if it goes inside the box and blue when it leaves. Now, my co-author, Miles, takes one of the phones out the front door and wanders up and down the street. I take 2 of the other phones out to the alley. As you can see, the phones are now mostly outside the query range. In this part of the demo, we show the solution working with real smartphones as we move them around in space. In part 2 of the demo, we again perform range queries, but this time we use a synthetic dataset. This input stream consists of simulated trajectories of mobile devices and allows us to show the solution working with a larger number of devices with greater mobility. Once again, the query device is shown with a red place marker, the query matches with orange place markers, and non-matches with blue. The geographic boundary of the range query is shown with a dark gray rectangle centered on the red place marker. As the simulated devices move around the space, their locations are streamed to Microsoft StreamInsight. This runs our standing query that invokes our user-defined spatial operator. This updates and queries our custom spatial index for the phones matching the range criteria, which are then output to the spatial output adapter.